Hi folks, welcome to 7.1, the law of sines. So we're going to continue on our trigonometry unit, which again should be a review from when you took trigonometry in the past, so 104 here at Mesa. And what we're going to do is we're going to talk about sort of this beginning part of the chapter, okay? So what we know so far is that we've learned a lot of rules throughout our academic career that only work for right triangles, okay? So we know some formulas that are only true for right triangles. For example, we know that sine equals opposite over hypotenuse, all right? That's only true for a right triangle. Cosine is adjacent over hypotenuse, and tangent equals opposite over adjacent. Those are only true for right triangles, okay? We also know this Pythagorean theorem, a squared plus b squared equals c squared, but that is, again, also only for right triangles. And then this last one, the area of a triangle equals 1/2 base times height. It's not that it's only for right triangles. However, in order to use this formula, base has to be perpendicular to the height, okay? And a word that you may have heard in the past is that instead of using the word base, we call it an altitude, and it has to be perpendicular to the opposite side, okay? So that's sort of some limitations in what we know about right triangles. Okay. Now let's take a look at some things that are going to be for all triangles. So we're going to learn something called law of sines in this unit. And that is 7.1 in your text. All right. We're also going to learn about something called law of cosines. That'll be in 7.2. And then we're going to learn also about how we can set up to find the area of a triangle when we only have 3 sides or 2 sides and the angle between them. We can also find those in section 7.2 of your textbook, okay? So again, this whole first section is about what do we do if the triangle is not right, and it turns out that there are some formulas we can use to figure out the sides and the angles of that triangle. Okay, so we're going to talk about the law of sines here. So the law of sines, and I'm going to go ahead and draw a non-right triangle, and I'm also going to make it oblique, meaning the sides are not equal to each other. None of the sides are going to be the same, okay? And so let's go ahead and draw one here. All right, so I've got a non-right triangle. I'm going to label this vertex A, I'm going to label this vertex B, and I'm going to label this one with AC. Now, some textbooks and some professors say that all of the angles are going to be capital letters, and then the sides that are opposite them would be lowercase. So the side across from capital A, or angle A, would be labeled little a. The side across from angle B would be labeled little b, and the side across from C, angle C, would be labeled little c, okay? So that's how some books do it. Your book does it a little differently, which is fine, but I just want us to be aware that there's more than one way to do this. So if I draw a second right triangle here, or non-right triangle, I'm sorry, they like to label their angles with Greek letters. So we would call this little angle alpha. We could call this one beta. And then gamma is the third letter in the Greek alphabet. So we have alpha, beta, and gamma. And so those represent the angles. And then the sides opposite those are going to be called little a, little b, and little c. Okay, so just to know that, like, if you don't see the angles in Greek letters, then that just means that maybe we're using a capital letter for it. But a lot of times the books will say, oh, here's the degree symbol, so you know that they're talking about an angle. Okay. All right, so what is this law of sines? Well, it turns out that if I take the ratio of the sine of one angle and put it over the side opposite that angle. So sine of capital A over little a. And I do that for every pair of sides and angles in a triangle. So sine A over A, sine B over B, and sine C over C, that these ratios are equal for every pair of sides and angles in a triangle. All right? So this is the whole law of sines. But I just want to make a note here for us that we're only using one or two pairs at a time. Okay, so even though the formula looks kind of long, we're only going to use two pairs at a time. All right, so we're going to jump right into some examples and kind of see how this works, and then we'll figure out how to apply this rule. If you don't have a calculator with you already, I would go ahead and grab a calculator, like of the scientific variety, and you want to make sure that you are in degrees, not in radians. Okay, so most of our work here is going to be in degrees, so just make sure that you have the right setting on your calculator. All right, well, let's try some examples. So, example 1, we have angle, side, angle, okay? So we're going to classify our examples into different cases, what kind of information is given in the triangle, and the direction for all of these is to go ahead and solve, which means we're going to find all the sides and all the angles, all right? So why would I call this one an angle, side, angle? Well, angle, side, angle comes from the fact that I have one angle, I have the side, and then I have another angle, okay? And just like I wrote the side in between the angles, the side that you're given has to be between the two angles, all right? So I can see here that 9 is between 34 and 76, okay? After you classify your case, what's really useful is to go ahead and write out the whole law of sines and see what information you have, okay? So let's go ahead and write out the law of sines, filling in the numbers that we have. So over here, I have sine of 76, because that's my A, over little a, because I don't know it, so I can't fill it in yet, equals sine of 34 over little b, I don't know that one either, equals sine of capital C over 9, okay? So one of the things we want to look for as we go through these problems is, do I have a full pair? Meaning, do I have a whole, like all the numbers are filled in this pair, or are all the numbers filled in this pair, or are all the numbers filled in this pair? And at first glance, you're like, no, it's not. And so how are we supposed to figure this out? But what we're going to do is we're going to go ahead and find angle C first. Okay, so I'm going to find angle C. And I'm going to do that by remembering that I can do 180 degrees, which is how many degrees are in a triangle, minus one angle minus another angle will give me how much is left in the third angle. And so it turns out that the measure of angle C is 70 degrees, okay? So I could actually go ahead and fill that in, and then I will have one whole pair with numbers. Now the pair that you have with numbers, that's what you're going to use to figure out all the other sides that we're missing here, okay? So I'm going to go ahead and fill in 70 in my triangle. I'll write it in... This is 70 degrees, okay? So all we're looking for now is little a and little b. Okay, so step 2. Step 2. I'm going to go ahead and find little a, all right? And so that's going to mean sine of 76 over little a equals, we're going to use the full pair we have. So not the b, but sine 70, which is c, over little c. And now we're going to go ahead and cross multiply. So I'll get 9 sine 76 equals a sine 70. And we want to isolate our a. So a equals 9 sine 76 over sine 70. Now you'll notice that I haven't turned anything into a decimal yet, and that is intentional. I really want us to take everything to as exact a number as we can before we round, okay? The earlier we round, the more likely we are to find that our numbers are going to be a little less accurate. So when I type all of this into the calculator, I'll get little a equals 9.293. And I would say that 3 is a good number of decimal places to round to, all right? So I found little a, and the only other thing I need to find is little b, and we're going to do that with a similar setup where we use the full pair we know to help us find the one letter we don't know. Okay. So I'm going to go ahead and squeeze that in down here. So I've got sine of 70, which is my c, over 9 equals sine of 34 over little b. And I'm going to go ahead and cross multiply again. So I'll get 9 sine 34 equals b sine 70. And I'll go ahead and squeeze my answer up here, b. When I calculate that out, all right, when I divide that sine 70 away, I'm going to get 5.356. And so I've got my a and my b and my c, okay? So now, since I've got all three sides and all three angles, that is considered having solved the triangle. Okay, let's try one more example for this part of the video. All right, so case number 2, a little bit different than case number 1. Case number 2 says that I have an angle, a side, angle, and a side. So angle, angle, side. So let's see how that translates in our diagram. I have angle C, that's my first angle. Then I have angle B, that's my second angle. And then I have side C, which is the side. So angle, angle, side. So anytime I look at the information in a diagram or from just numbers and I see that I have an angle, angle, side, I can use law of sines. So I'm going to go ahead and set this up. So I have sine of 35 over little a equals sine of capital B over little b equals sine of 62 over 7. Okay? Now again, we want to see, do we have a full pair? So I see that I have this, which is not a full pair. This one is definitely not a full pair, and this one is a full pair. So what I can do here is I have a few choices, all right? So the way that you do this, it doesn't necessarily have to be in this order, but I'm going to go ahead and find little a first. So find little a. All right. So I've got sine of 35 over little a equals sine of 62 over 7. And when I cross multiply, I get 7 sine 35 equals a sine 62. And I get little a equals 7 sine 35 over sine 62. And when I turn that into a decimal, I get 4.547 for my little a. Okay? Now, some of you may have looked at this problem and said, well, I have 2 of the angles, so let me go ahead and find the third angle first, and that's absolutely fine. And we can do that by doing 180 minus 35 minus 62, and that will give us angle B equals to 83 degrees. Okay? And now we can use our law of sines to figure out little b. So sine of 83 over little b equals sine of 62 over 7. 7 sine 83 equals b sine 62. and b will equal 7.869 once we work that out. All right, this is a good place to stop here, folks. Come back for part 2.